Okay, so today we are looking at factorising the difference of two squares. We know that factorising is the opposite of expansion. So previously, if you had a question such as a plus b times a take b and you went to expand that, you would have a squared take ab plus ab then minus b squared. So anytime we have a plus or minus separating the same terms, those two middle answers, the plus ab and the minus ab, will actually cancel out and you'll be left with a squared take b squared. Okay, so I'm going to have a look at the first question from the textbook, which is an example 11, which is 9 take x squared. So just looking at that heading there, the actual topic, difference of two squares, difference meaning subtraction, and two squares meaning we've got a squared take b squared, so the difference of two squares. So the first thing you always want to ask yourself is there a common factor that we can subtract out? In both of these cases, from the examples, there's not actually a common factor, so that first step we don't have to worry about doing. What we need to try and get now is into this form of a squared take b squared. So with the first one there, the second term is already in its squared format, so x squared, so that's fine. But the 9 at the moment isn't in that format. So we need to change that so that 9 is something squared. And I'm just going to start by writing the actual question as always. And we know that 9 is 3 squared minus x squared. So now we've got it in this format, a squared take b squared, where a is the 3 and the b is the x. So at that point there, all we need to do in order to get it back out and to factorise that is, I'll just start by putting my brackets. So it's going to be a plus b and then a take b. So in this case, the a is the 3. So I can put that on both sides. And then it's always going to be separated plus on the left and minus on the right. And in fact, it actually doesn't matter which order you put those in. But we always generally put the plus first. But again, it doesn't really matter. And the second term is the x. So that just goes there. And that just goes there. And you can always check your answer by re-expanding that. And you will find if you go through that, just with a different little colour, you get 3 times 3, which is 9. Take 3x plus 3x, which cancels each other out, those two. And then we'll get minus x squared. So we've got 9 take x squared. So just to check, we've actually got the right answer. With the second one, 4x squared take 25. Now, just be really careful, even though the term on the left looks like it's already squared, that squared is only applying to the x at the moment. It's not applying to the 4, because that means 4 times x squared. So with the a and the b, they can be like a number and a letter at the same time. So in this case, we actually need to make sure that we've got that in its squared format. So 4 can be broken down to be 2 squared, and the x squared is obviously x squared. So we will change that now to 2x squared. And if you think about that and you multiply those two together, 2 times 2 is 4, x times x is x squared. So it's really important that you put brackets around that. Now we've got a, which is, in this case here, this is 2x. Okay. The 25, we can change that to be in its squared format just by going 5 squared. So now we've got a squared take b squared. And I'm just going to write on the side here, a equals 2x and b equals 5. So last step is to put it into its factorised form. It's going to be a, which in this case is going to be 2x. And then the left-hand side will be plus the b, which is 5. And the right-hand side will be minus the b. And again, you can always expand that to check your answer that you're getting what you've got at the start, which is 4x squared take 25. So really important in that case there. I just want to reiterate that this here needs to be 2x all squared. Okay, so just be really careful that you don't just assume that that is a 4x for the A. So I'm going to look at the next couple of examples. If I can find my cursor. And we've got the same questions again. So, as I mentioned before, you need to make sure that you can or can't extract out a common factor. So in this first one, we've got 2x squared take 8. So let's write the question out first. We can actually get 2. 2 is the highest common factor from both of those terms. So that's the first thing you want to do, is just extract it out. Put it to the side, on the left-hand side, and then ask yourself, how do we go from 2 to 2x squared? We multiply that by x squared. And how do we go from 2 to 8? We times that by 4. Okay, so all we've done is just extracted out the highest common factor, which in that case there is 2. Now we want to do exactly like we just did in example 11. Just leaving that 2 out on the side there, and then away we go. So x squared take 4. In that case there, the first term is already in its squared factor. And then the second one, the 4, we can change that to 2 squared. So in that case there, I'll just write it to the side again, just so it can really be clear that A will be x and the B will be 2. So last thing we need to do is just put those 2 brackets, and then it's A plus B, A take B. So A plus B, A take B. Okay, so no different from the top one. The only thing is the first thing we did was extract that 2 out. With the second one, I will write the question out first. So minus x cubed plus 36x. So we want to extract our highest common factor. So in this case here, the number 1 obviously goes into both of those, but also so does minus 1. But also you notice that x is on both sides. So x is a common factor. So x will go into both of those, and also minus x will go into both of those. So we want to extract the minus x, and I'll just explain why that is first up. So all I'm going to do is just first of all take out my minus x. How do we go from that to minus x cubed? You just times it by x squared. And then how do we go from minus x to positive 36x? So it needs to be minus times a minus. And we want to times that by 36. So again, if just to check that, to expand that out, we would have minus x cubed, and we would have positive 36x. Now, the reason we extracted that minus x instead of the positive x, if we did the positive, then this sign in between these two terms would be a plus. Now, we obviously are working on the difference of 2 terms, or 2 squares, so that's why that needs to be a minus in between there. So we're going to do exactly the same as what we did before, minus x, keep that on the outside. X squared, that's already in its a squared format. And then 36 can be changed to 6 squared. All right, now we've got a squared take b squared. All right, on the side, a will equal x, b will equal 6. And you don't even have to think about whether or not that's plus or minus. It's always just going to be a positive integer or a term or pronumeral on the right-hand side, because the middle sign will always be negative. So last thing, we've got a minus x on the outside. We want to have 2 lots of brackets. And it's a plus b, a take b. So a plus b, a take B. I wrote B as a was saying it should be 8x takes 6. And again, sound like a broken record, but you can always check your answer by expanding that, and you should get back to your original question. So just remember to first think, can I get out a common factor? And if not, like in example 11, then away you go. And then if you can, you want to put it to the side and then just put what's left over in brackets there. The next step is to get it into the a squared take b squared format. Okay. Sometimes it will already be in that format. Sometimes, like the 9, you'll need to change it to 3 squared. And sometimes, like the 4x squared, you'll need to make sure that that number is turned into a squared number as well, such as the 4x squared.